Hello everyone, welcome back to another video. It's been a hot minute, but I'm Peter.
Caitlin.
We're here to work through some SAT practice questions, and hopefully you won't get to see how bad we are at math.
If this boost your score, that would be the goal.
The goal of this is to help you get some practice and give you more confidence in math, so hopefully you'll learn a few things. So we've got our problems here, we're going to write them out, and we're going to work through them, and hopefully we won't have any trouble.
So this is from Bundle 11 on the College Board site. So let's look at this first one. I'm just going to draw what's given. We have a nice little triangle here, P, Q, R. And we have, let's see, 24 degrees, 132 degrees, and X degrees. Figures not drawn to scale. In the triangle, PQ is the same as QR. What is the value of X?
So we just need to know what type of triangle this is.
Well, we could go from two routes. You take it from that route. I'll go the route I would go.
Okay, so first thing that I'm looking at is knowing that sides PQ and QR are the same length, I'm thinking this is an isosceles triangle. So with it being an isosceles triangle, if the side opposite of P, which being QR, so if QR is some length and PQ, it has a corresponding angle of 24, then the other side, PQ, that has the same length, it also has the same angle of 24. So I'm going with 24 degrees.
Okay, I'll go from a perspective of, maybe I didn't know that fact. I forgot all about isosceles triangles, so couldn't tell you. So what if we know what all three angles in a triangle add up to be, right? It's all 180. So what if I subtract the 132 and 24? And there we go. 24.
Oh, we get the same thing. You know, honestly, when I looked at that problem, I didn't even read the question in full. I just said, okay, there's a triangle. Looks like we're trying to find X. Okay, so I immediately just thought exactly what you did. But with the given information, like, oh, well, you don't even really have to do a lot of math at all. You can say, oh, that's an isosceles. So those two sides have to be the same angle, or those two angles have to be the same.
Right. So either way.
Either way works perfect. So we love that. We love have different ways to get to the same answer.
Exactly.
All right, so go ahead. I'll let you write it.
We got 4x plus 1 equals 33. And it says, which equation has the same solution as the given equation?
Ooh, okay. So
let me.
What are you thinking? What are you thinking?
My thought is I'm going to write the answer choices here to see what we can do from that. Because
just like you do to use the answer choices.
It is, but I think I already see the answer, and so that's why I want to write them here instead of just going with it.
Right.
Because my first thought is, hey, solve this equation and find what X is.
Right. Okay.
So maybe let's do that. And then I could divide both sides by 4. So now I'm looking over here for an equation that is going to have X equals 8. Well, this is what I see. I'm looking here, and I see 4x is 32 and 4x is 32. So I didn't even have to solve for x. So I'm going to say I'm going to go with A.
That's exactly what I was thinking. I noticed all the answer choices. So here's where you would want to use your answer choices. All the answer choices have 4x isolated. So with 4x being isolated, just isolate 4x and see which one matches up.
That's crazy. I didn't even notice that. I did not look at all the answer choices. I saw the first one and said, if I subtract 1, I get 32.
Perfect. All right. I like that one. That one was easy.
Yeah. All right. For the linear function f, the graph of y equals f of x is in the xy, I don't know, I'm writing all these details. XY plane has a slope of 7 and passes through the point 0, 5. Which equation defines f? So I'll put the answer choices again. But since I took the last one, what would you do with this one?
Let's see. Actually, I wasn't even really listening. So let's see, has a slope of 7 and passes through 0, 5. Okay, so it tells you the slope and it tells you the y-intercept. So if you know the slope is 7, you should have, if we're looking at y equals mx plus b for our slope-intercept form, it should be, so we have y equals mx plus b. We know that m is 7 and the slope-intercept is 5. Sorry, the y-intercept is 5. So should be 7x plus 5.
Should be C. Yeah. All right.
Perfect.
Easy enough.
Is that how you would end that one too?
Yeah.
Gotcha.
Maybe.
Technology's hard.
Yeah. Okay, so we have 8x squared minus 40 equals 32. What is the positive solution to the given equation?
Okay, so I think it's important. I mean, if you don't have answer choices, that's important to pay attention to.
Yes.
But we do have answer choices here. So do we want to write down our answer choices?
I mean, we sure can, but the thing I notice is the question says which one's the positive one, and all the answer choices are positive. So to
Right.
me, that's not very helpful.
So it's kind of irrelevant.
Right.
Now, I know some people, they might just, oh, well, I've got answer choices. I can just plug them in and see which ones work. So which one works. How I first looked at this was solving it like I know. So you're going to add 40 to both sides. And I believe that's 72 if I know how to add. And then I'm going to divide both sides by 8. So I have x squared is equal to, I'm thinking that's 9. So 8 times 9 should be 72. And then when you square root, you get plus and minus. I'm going to put the little square root symbol over this. You get plus and minus 3. So we have 2 solutions, which is expected because it's a quadratic equation. And it only wants the positive one, so that would tell me I take away the negative root, and that would give me just the plus 3.
Yep.
I wonder how many people would have divided by 8 first.
I don't know. You can, because they're all divisible by 8, right? So that should work.
Yeah.
So you'd be what? X squared minus 5 equals 4.
Yeah, there you go.
And then add 5. And then you're back at that same point.
Exactly. Look at that.
GCF. Ooh.
Oh, we're already on the back?
Yeah.
Oh, gosh. I see a table and lots of words.
Okay, so yeah, I'm going to draw the table. Maybe you read the rest of it while I draw the table.
Okay, it says a total of 50 children attended a summer camp and were offered 4 types of sandwiches. The table shows the number of children who chose each type of sandwich. So we've got 4 different kinds of sandwiches here. We've got a tally or a count of who got which sandwich. So it looks like there's 15 turkey sandwiches, 23 chicken sandwiches, 3 ham sandwiches, and there was 9 veggie sandwiches, vegetarian. And the total is 50. So if one of these children is selected at random, what is the probability of selecting a child who chose a vegetarian sandwich? Oh no, we're in statistics world now. We're no longer in algebra world.
I know, that's a little scary.
Oh gosh, not statistics.
Okay, so we want probability of veggie sandwich. So probability comes from number of occurrences over number of total. So veggie sandwiches was 9. How many total kids were there? 50.
Looks easy enough. And based on the answer choices, looks like that is answer choice B.
Yes, I didn't write out the answer choices.
That's okay. We don't always have to write out the answer choices.
I'm not a big fan of multiple choice.
Sometimes it's smart to use the answer choice just because it's faster sometimes, but it's better to just know how to do it. All right, so number 6, it says, Amara grows cherry tomatoes in her backyard. This year, she harvested 750 cherry tomatoes and gave 10% of them to her neighbor. How many of the harvested cherry tomatoes did Amara give to her neighbor? So it looks like she gave 10% of them. I'm having some deja vu here. I feel like I'm fondly remembering a conversation about calculating a 20% tip.
Yes.
So this is even easier because it's not 20%. It's only 10%.
So we'd only have to divide it. We would divide it by 10 instead.
So you just move the decimal over, left one. No doubling. I just divide by 5.
Well, that's what I was saying. Divide by 5. So what would this be? I was like, okay, divide by 10.
Oh, sorry. We have to, divide by 10.
Yes.
So I say, well, we'll correct that. We'll just double it whenever we divide by 5. No, divide by 2 again, because that's dividing by 10. See, right. Caught myself.
Okay, finding 10%. We got a total number. We want to find 10% of it. So we can multiply it by what I call a usable decimal. So instead of 10%.
Usable decimal?
Yeah, we can't use percentages. This is what I tell all my students. We want a usable decimal. I can't use 10%. I'm going to use 0.010.
There you go.
You don't need the 0 on the end, but it's okay.
Where'd the 0 go? I'm already confused.
Don't say that. And then we can just do that multiplication. And what are we going to get? We are going to get 75. And you know what? I didn't look. Is this the calculator active or inactive part?
Oh, that is a good question.
So let's pretend we had a calculator and we got to 75. Let's pretend we didn't. This is the calculator inactive. So we want 10%. 10% is an easy number to work with. We can just move the decimal one spot over. And we have 10%. It's okay.
This must be the inactive because I think the second part is
Gotcha.
Calculator active.
Okie dokie.
So let's scratch all those problems. We use the answer. Actually, no.
We didn't use a calculator.
We didn't use a calculator. We don't need a calculator.
Exactly. But we could also do it this way, maybe. If we didn't have a calculator, you could multiply it by 0.1. Go the old school way. 0, 5, 7. Move the decimal. Ta-da. 75.
Say, I think I forgot how to multiply with decimals. Oh, you know what? I want you to do number 7.
Okay.
Yep,
perfect.
I'm looking at that. I'm like, ooh, I want you to do it.
X plus Y is 125. X plus Y is 155. What is the solution? Oh, sorry. The solution to the given system is X, Y. What's the value of Y?
It only asks for Y.
Yeah. So first thing I see is I'm going to combine like terms.
Okay.
And then if I want Y, I'm going to eliminate X.
Oh, okay.
So I'm going to subtract all of that over, because then that X will eliminate. I'll be left with negative Y equals negative 30.
I think it's 30. Mm-hmm.
Try and do this without a calculator.
All right.
And then, hey, they're both negative, so I can actually just divide by negative 1. Y equals 30.
Perfect.
How would you have done that?
That's definitely not what I would have done.
Really? What in the world would you have done?
So, giving your system up here, you know X plus Y is 125. So I would group X plus Y in the bottom equation and say 125 plus Y equals 155.
Ooh, so
and then when you subtract, you get the 30.
My brain does not work like that.
That's exactly why I wanted you to do it. Because I don't think she's thinking what I'm thinking.
All right. In a chess tournament, each participant earns 1 point for each game the participant plays that ends in a draw, and 3 points for each game the participant wins. A certain participant in this tournament has earned 41 points. Which equation represents the situation where D represents the number of games this participant has played that ended in a draw, and W is the number of games they have won? Wow. This is only one equation of a system. If we look
Interesting, right? Yeah.
So D represented draw, which was 1 point. W represents a win,
which is 3 points.
Just 3 points. And then total, they had 41 points.
Right.
So the number of draws plus the number of wins equals sum total. 1 point for draw, 3 points for each win for a total of 41 points. And really, you don't need the 1.
Right. Well, it looks like that's answer choice A.
Yeah.
So when I was reading this one, I was like, oh gosh, I don't know if I know how to do this one. But whenever you started, I don't know, the more you started talking about it, I'm like, oh, it's just like a system of equations where you're like, oh, we know the total number of games they played, and we also know the total number of points that they. So this would just be like half of that system.
Right. Like if they told us, I'll do it in a different color. They played 6 games. We could say D plus W is 6 and solve for how many they've won.
Right. Exactly.
But it didn't.
Right.
All right, next page.
All right. Let's see. We're done with that one. We are chucking along. The function g is defined by g of x equals square root of x plus 300. What is the value of g of x when x equals 81? Oh, this one's easy.
Well, you also got to think it's no calculator.
Well, I mean, as long as you know your perfect squares.
So it tells us x equals 81. So we're going to find it.
And then plus 300, yep.
So square root of 81. 9.
It's 9. Yep, that's exactly
Plus
what I would
300.
have done.
So 309. Now, how come, I'm going to ask you this, how come I did 9 and not negative 9?
So if my understanding is correct, or at least what I was told when I was in school, that it's asking for the principal root. The principal root of 81 is going to be the positive. And if it was asking for the negative, there'd have to be a negative sign in front of that.
Yeah, that's what I tell my kids. If you are the one taking the square root, like you have added it in, you need both. But if it's already given to you, you take the sign that's in front, which there isn't one, so it's positive.
Right. Yeah, I tell them, so I think about like, if you have x squared equals 81, 9 and negative 9, like they both satisfy that equation. Right. So like that's why you do plus and minus, because you're squaring the value.
Right.
All right. Number 10, a cable provider wanted to know how many of its 30,000 customers would be interested in a new service plan. The provider selected 300 customers at random and asked each customer whether the customer would be interested in the new plan. Did I read that pretty bad, or was that...
No, I think that's...
Okay, so that was like, wow, I'm getting confused reading that.
Mm-hmm.
Of those surveyed, 8 said they would be interested. Which of the following is the best estimate of the total number of customers who would be interested in the new service plan? Interesting.
I think this is a proportion question.
Right. So, yep. So it says 300 customers at random.
Right. So
of that, they said 8.
So 8 of those 300 said they would be interested in the new plan. And we want to know, how much does that represent in that total of 30,000?
Yes.
Yes.
So... how would you go about solving this, or do you want me to do this one?
You could do this one.
Okay.
And then if I would do something different, I'll tell you.
So I would try to get a common denominator, because this is 30,000 over here. This is 300 over here. So you want the left to be 30,000, right?
Okay.
So you would have to multiply the numerator and denominator by, well, you need, so if you're at 30, you need 3 more zeros. So you have to multiply by 1,000, right?
Yeah.
So you would multiply by 1,000. Over 1,000, so 8 times 1,000. 8 times 1,000 is 8,000. So that would be your x.
I feel like we have an extra 0.
10 cubed.
But then that would be 300,000.
Okay, so we need to change that.
I think it's 100, not 1,000. Right, 300 times 100 gives us 30,000. So it's 100.
I'm bad at math.
It's okay. So we have 800 instead. Okay, that's kind of how I would have done it. I would have thought, yeah, what do I have to multiply 300 by to get 3,000? Mm-hmm. Just because there's zeros and you can work nicely with the zeros. But my initial thought was cross multiply.
Oh, I should have just crossed out 2 zeros.
It's okay. I would have thought cross multiply.
Right.
So 300x equals 24, and then 4 zeros. And then divide by 300. So without a calculator, I get rid of those 2 zeros. That's 8, and there's 2 zeros left over.
Well, we know who would have got the first question wrong.
All right, 11. Which expression is equivalent to this one? So 64 t squared s cubed minus 56 t cubed s. All of the answer choices look like a GCF was pulled out.
Right. But not completely. Not all the answer choices have a GCF pulled out because they're 16 and 14, so they didn't factor out any. They only factored out a 4 based on their answer choices. So they didn't factor out a full GCF.
Gotcha. Weird. Because we always teach the kids to
factor out the
greatest common factor.
Greatest common factor.
Not a partial one.
Right.
Gosh, maybe that's why they do partial derivatives. Okay, so let's go from that aspect then. All of the answer choices, I know you can't see them.
Have a 4 factor.
But you know what? I'm going to write all the answer choices so we can look. I'm going to pause this. Okay, so if all the answer choices, have the 4, 16, and 14, then we're just looking at the letters.
Right.
So did they pull out all the letters? I don't know. Let's find out. I guess we can look at the first 2 answer choices and pull out just T and S and see what's left.
That's what I would do.
So, well, wouldn't we be left with we'd have to be left with a T here because there's 2. If I pull out 1, there's 1 left over. And there's not here. So.
Correct. It can be that one.
Okay. Well, here's this one. It's having 2 left over, but we already took 1.
Right. So that can be it.
Yep.
And then for this one, so you would have a T and an S left over if you factored out. Sorry, now it's not the T. So now we're doing the T squared. So factor out a T squared. So you're not going to have a T squared left over. Right. So that one's going to go. So it's got to be that bottom one.
Yeah. Ta-da.
Ta-da! Efficient.
Another system here. X plus 5 is 14. Y equals 4x squared plus 4. But what is it actually asking us to do? At what point, x, y, do the graphs of the equation in the given system intersect? Okay, so solve the system.
Okay.
What would you do? Oh, x plus 5 is 14, so I'm going to plug in 196.
No, actually, I would just solve for x in the first equation because it's just not, that's the only variable there.
So is it 9?
Yeah. So x is 9. Now, I would maybe factor out a 4.
Oh.
Just to
make it easier.
Just to make it easier. So if you factor out a 4, you would have a 9 squared plus 1. So you're really doing 4 times 82, right? Because 9 squared is 81. So 8 times 4, that's 32. So, but that's really 320. And then 4 times 2 is 8, so 328.
Okay. See, I would have continued with this one and done 4 times 81 plus 4 and did 81 times 4. So 324 plus 4 is 328.
Woohoo!
Well, we need our final answer. So we need it as an ordered pair. 9 and 328.
Perfect. And that is answer choice B. All right, I'm going to let you start this one.
Okay, let me write the equation. So I have 8x plus 7y is
That's an
170.
11y.
Ah, it sure is.
I should have let you continue and be like, you're wrong.
The equation gives the possible combinations of the number of 2009 premium grade log cabin pennies, X, and the number of 1996 select grade Lincoln pennies, Y, in a collection that is worth a total of $170. If there are 6 1996 select grade Lincoln pennies in the collection, how many 2009 premium grade log cabin pennies are in the collection?
Ooh, okay. Thoughts on this one?
This is an easy question. X is the 2009 pennies.
Mm-hmm.
Y is the 1996 pennies. It told us there were 6 of the 1996. 8x plus 11 times 6 is 170. Let me factor out a 2.
Oh, gosh. You like making fun of me.
Yep. I don't like that.
Oh, no. Is that 104?
Right? Did I do something wrong?
What is that? 12 plus... no, not 12. So it's 96 plus 8, right? 96 plus 8 is 104. And both of these are divisible by 8, right?
I don't think 76 is.
That's a 9. It's a terrible.
Oh, it's a 9. Yeah.
Is that a 12?
Yeah.
Yeah, so it'd be 12 plus 1, 13.
Oh, because 8 goes into 10 one time. 24, 8 goes into 24 3 times. 13?
The normal way.
I was wondering if my 104 was right. Okay. Yeah, he's got some weird voodoo math over here. It works, but voodoo.
Yeah, I was just trying to think of a number that... two numbers that were both divisible by 8 that added to 104.
Creating your own system.
Yeah, pretty much. All right. The population of a town of Smithville doubled every 75 years from 1659 to 1959. Okay, the population of this town was 240,000 in 1959. What was the population back in 1659? Interesting. Okay. So it doubled every 75 years. It's like a linear function. If it doubled it, every 75, I was first thinking of like exponential growth.
Right. It's going to double every time.
Yeah, because I'm dumb. Well, I was thinking, I don't know what I was thinking. I was thinking it's like, surely exponential functions are on here somewhere else here.
And we already know the double time is 75 years. And how many years had passed? 100? 300.
300.
Okay. Oh. This is still no calculator one, though.
Well, 75 times 2 is 150, so 75 times 4 is 300, so that'd be 4.
Okay. So 2 to the 4th?
Yep, which is 16.
Okay. So 16 times that initial population, I'll just leave it on the left, is that 240,000.
Mm-hmm.
And then 240,000 divided by 16. You're going to break that up into numbers?
I thought about it.
What's that, 8? Right? 60, yeah. And then 5 and 3 zeros.
So 160 and 80. It makes 24, yeah. Mm-hmm.
So then 15,000.
There you go. This is why she's the smart one. All right. The scatter plot shows the relationship between x and y. Oh gosh, do we have to sketch the scatter plot?
Probably.
A line of best fit is shown. Which of the following is closest to the slope of this line of best fit? Dang.
Oh, it's okay. I can do my best. Let's just do some clear points. So off this graph, I want like the clearest ones. So it looks like there's a point here at 3, 5.
Yep.
And then is there another clear point?
Up here.
Oh, yep. 8. 8. We can find a slope between that.
Yep.
So 5 minus 8 over 3 minus 8. 3/5, 0.6. Is that an answer?
Answer choice A.
Alrighty.
You're so fast. Which quadratic equation has exactly one distinct real solution?
You want to know my initial thought based off those answer choices?
What's that?
None.
None.
I looked at that and said, oh, look, they're all squares. But they don't all equal 0.
Here, we're going to write
that
out
one.
the answer choices.
Yeah.
Yep. So
Alright.
it's not B because those would be imaginary or complex solutions because you'll have an imaginary part and you'll subtract over a real part. So you'll have 2 complex roots.
Okay.
And then C, it's not that one because you'll have plus and minus 45. You'll subtract, so negative 15 plus and minus. That's 2 distinct roots. It's basically a quadratic shifted down 45. And this is a quadratic shifted down 135. So that's going to have 2 distinct roots. So it's got to be the first one. That kisses the x-axis at 15, negative 15.
That's a choice word.
Touches. That's what I was taught. Kisses the x-axis.
Gosh. Dr. Crocker.
Oh,
Did you ever have her?
No, I did not.
Okay.
She would probably not like the things that I say.
I think about her all the time and about the proper terminology and what does kiss the axis mean? Because
It means where it gets really where it bends there. The parabola is really puckering up like and kissing the x-axis. That's what's happening. It just gives nice little peck. Have you recovered?
Maybe. Let's see.
Maybe not the best choice words there.
Touch and cross. But then Dr. Crocker's in the back of my head of what does that mean? So intersect and tangent.
Oh, interesting.
Tangent to the x-axis and intersecting.
I mean, I see that. Wow. Yeah. Maybe I should start saying that. It'd probably be better than what I say.
Okay.
The cost to rent a bus from Company X is $950 for the first 3 hours. And an additional $50 per hour for each hour after the first 3 hours. If the total cost to rent the bus from Company X for T hours, where T is greater than 3, is $1,150, which equation represents this situation?
Mm-hmm.
Okay. So I'm thinking that if it's 3 hours forward, so you're getting billed for a flat $950 for the first 3 hours. So it's a constant. So it's like a slope-intercept form. Plus, and then if it was 12 hours, you'd subtract off 3 of those to know how much is being billed at the $50 rate. So you're always going to subtract 3 off the total number of hours. And that's going to equal the total.
Yep. That's what I would have done too.
Perfect. Oh, we're on the next one. My eyes are still watering. Let's see. All right. I think this is the next one.
Yep. So x plus y is 53. 11x plus 18y is 730.
The given equations represent the possible numbers of beach chairs x and umbrellas y rented at a park last month, and the total spent in dollars to rent those beach chairs and umbrellas. Which of the following graphs represents the situation? So x plus y is the total number of chairs and umbrellas, and then the 730 is the cost.
I'll do my best to try and draw these graphs here. So this is over here between 60 and 70. This one, I'm going to pause the screen so I don't waste time. All right. I, with multiple choice, like to get rid of some obvious ones if we can. So ones that I see that are obvious is this first one here, because it starts at 0, 0, and I don't think either of those start at 0, 0.
Right.
So get rid of that one. Mark it off in blue. And then both of these, none of those are constant functions like this last one has. So I'm between these two here. So now I just want to find the intersection point and find, is my intersection closer to, we'll say 30 and maybe 22-ish? Or is it closer to 10-ish and 45-ish? So which one is it closer to? That's what I would do.
Okay.
Is that what you do? I'm gonna solve the system. But...
Well, actually, I already have the answer without having to solve it. So, but I mean, I'm like you. I would eliminate some answer choices. Well, first of all, when I look at the first equation, x plus y equals 53, if you were to subtract x over, that's the line y equals 53 minus x. So you've got a y-intercept at 53 and an x-intercept at 53. So I would look and see which ones have an x and y-intercept at 53. So I know this one does. The first answer choice does not.
Yeah.
Looks like B does. So B's a possibility. C's a possibility for that because there's two lines, and then D is not a possibility. So that would eliminate those two. And then I would look at the slope of the second line and see that the slope's negative because you would have to subtract 11 then divide 18. And B, both of them have negative slopes. And C, one has positive, one has negative slope.
That's so much smarter. Oh my gosh. Why did I squared the wrong one?
So that's how I would have gone about that one.
That's a lot easier. I would have done the system and solved it.
But if you didn't have the graphs, you'd have to solve it as a system.
Well, there we go. You know what? I'm going to solve it as a system because I'm sure there's people out there going, no, let her finish the system because I would have done that too. Nothing fun with this one. I would probably, and it's the no calculator one too. Ew. So this isn't fun at all. Okay, I like elimination best. So I'm going to multiply this one by negative 11.
Yep, that's what I would do.
So the x's will cancel out. So I'm left with negative 11 plus 18. So is that 7y?
Yep.
And then I got to figure out what 53 times 11 is. So 5, nope. Because then I also have to add that. It's a negative. And I have to add 730. So I need to work backwards and subtract like an old person.
I cannot keep up with what you're doing.
And then that's going to be 21. And look at that. I said 22-ish.
Wow, look at that.
And that's closer than the 45 was.
How'd you know that was 21 so fast?
14 and 7.
Oh, so you did the same thing that I did. You broke it. You
no. I did 147 divided by 7. 7 goes into 14 twice. And it goes into 7 once.
Oh. Hey, I wish I could see that in my head like that.
You see the complicated way in your head easier.
All right, so number 19. Oh, it's a right triangle. In triangle QRS. So Q is the top, R is the right angle, S is the other one. 18 is the length of SR. In triangle QRS, side length QR is smaller than side length RS. So that vertical distance is shorter than that horizontal distance. Which expression represents the length of QS, so the hypotenuse? Okay. They're using Q as the angle.
Yeah, I'm going to write all the answer choices here.
It's kind of weird.
B is 18 cosine Q. B is 18 sine Q. C is 18 divided by cosine Q. And D is 18 divided by sine of Q.
Okay.
All of them are using Q.
Yep. So it has to be the reference angle is Q.
Yep.
So I would do sine or cosine. So if you don't know, oh wait, sorry.
All the answer choices either have sine or cosine.
Oh, I didn't So I was just saying, like, you know the 18, that's corresponding to using sine. So sine's opposite, SOHCAHTOA, opposite over hypotenuse. Okay, so then you multiply both sides by the hypotenuse, divide both sides by sine of q. And I guess you could also do cosine, but you'd have to know that side length to do cosine.
Right.
And we don't know that side length. We just know it's
Well, I
this.
wonder. We know what the hypotenuse is now.
Oh.
Can we go the opposite way and find this one? So you still do cosine. So cosine of q is x over that. Will it give us another answer choice? I don't know.
Oh, yeah.
And then
Look at that. Oh, well, 18 is sine of q times cosine of q.
Do it.
Oh, never mind. I was looking at it wrong. Yeah, multiply both sides by 18 sine of q over sine of q, yeah. Okay, so 18 cotangent. Yeah.
But that doesn't have anything here.
Right.
Dang.
Interesting. That one wasn't bad. That was fine. Circle A in the xy plane has the equation x plus 5 quantity squared plus y minus 5 quantity squared equals 25. Circle it, so we know the center of that first one is negative 5, 5. Circle B has the same center as A, but the radius of circle B is 2 times the radius of circle A. All right, so the radius of A is 5, so I mean the radius of the other circle is 10.
We're finding K. Yeah.
Oh, K is 10.
Okay, the radius is 2 times this one.
Oh, sorry,
yeah.
that's 10. That's 100.
So this here, to find the radius, you just square root it. And then to double it, we want 10. So then to square it.
Yeah, so here it doesn't have
100.
K squared. It just has x plus 5 quantity squared plus y minus 5 quantity squared equals K. So it wants the squared value.
Right.
Right. So that's the tricky part. Interesting.
Interesting wording for this one.
Yeah.
So one solution to this can be written as x equals negative 7 plus the square root of k over 2, where k is a constant. What is the value of k? So what would you do for this one?
Well, I was trying to think of a sneaky, clever way to do it, but I'm feeling like I'm having to resort to quadratic formula.
Well, yeah, you just want to know what the discriminant is.
Right.
It's the only main part of it. So you don't need to know the whole quadratic formula.
Right.
Just
so
need
it's
to know
going
what's
to be
under the
b squared
radical.
minus 4ac.
Exactly.
So you would just find that with the given equation. So it'd be, yeah.
29.
I trust your math better than I trust my own. Easy enough. All right, so we have a scientist measured the lengths of 240 gray seals from, how do you say that?
I don't know. Muskeget?
Muskeget. I don't know. Muskeget Island, and 120 gray seals from the Sable Island. The scientists determined that the mean length of the 240 gray seals was 88 inches. That's from that Muskeget Island. So there was 240 from that one, and the mean was 88. Okay. And then the mean length of the other one, there was 120 from the other one. The mean was 94. What was the mean length of all 360? Interesting. Okay. What are your thoughts on this one? Well, Okay, I have some thoughts. Let's try. Okay, so we know there's 240 in total, right?
I had 88. Me and 88.
Right. So the first average you had to have divided by 240, right?
Mm-hmm.
So we have some number, let's call it x. Okay. And then, so we'll say average 1. We'll call this, I'm about to write a 2. Average 2. So the other average, we'll call it y, had to have been divided by 120, right?
Mm-hmm.
Okay. So we know that this mean was 88. This mean was 94.
Yep.
So we can find both x and y.
And then.
So you would do x plus y, the mean of all of them, that'd be over 360.
Mm-hmm.
So you would have the 88 times the 240 plus the 94 times the 120 all over the 360.
Yep. This is a no calculator.
Yeah, I'm trying to think. Well, surely we can, surely there's something we can do.
Ooh. Can't we take out 120 throughout the whole thing?
Yeah, so you can factor out 120.
So this would now become 88 times 2 plus 94 over 3.
Okay, that's definitely more manageable.
I think so. 88 times 2 is 176 plus 94.
Hey, let me write in
And
something
then
so it's a
divide by
little,
3.
so it's a little easier to see. So if you're trying to catch up to speed, so this quantity is being divided by this quantity is being divided by the same thing. So she was just looking at this stuff right here. And because everything's multiplying and dividing, she did this one. She divided out a factor of 120 out of this one and that one, right?
And that one.
And then over here on the right-hand side, you did that as well.
Yeah.
Okay.
So 90.
Look at that. You're so smart. I don't even know if I would have noticed that.
I went from your method. What can we take out? They all have a 0 in them, so at least 10.
I've been like, well, I know everything's divisible by 2. Let's take out a 2. Oh, we can take out another one. We can take out another one. But yeah, that was a much better way to do it.
I think we need a new page.
I think so.
Okay, I'm curious. I don't remember the time limit we get.
It's time.
I know that we yap a lot, but we're at 47 minutes.
Oh, dang.
And we only have what? 1, 2, 3, 5 problems left? I think we're good on.
Yeah, I don't know how long we typically have.
Okay, we have a picture of a graph. I'm going to do my best to try and draw
Y-intercept
it.
at 8, x-intercept at 2, and it looks like a exponential function that's been flipped.
Looks something like that. All right, graph of f of x plus 4 was shown. So, what equation defines f of x? I'm going to write the answer choices. Okay. So we want, what is the one that's shown? What is the original function? So transformations. This was shifted up 4 from our original.
Up 4? Oh. I didn't see that part. I was just looking at that. Okay, gotcha.
So then the original one, the y-intercept would have been what, at 4? Because it's just shifted up 4.
So you
right?
have to,
Shifted down 4.
Yep.
So if what we have, looking at all the answer choices, it looks like the function is negative 3 to the x.
Mm-hmm.
So it would have been plus 8.
Well, actually, there's a horizontal asymptote.
Not.
So, like, when you look at the standard exponential function, there's a horizontal asymptote at 1. So when you flip it, there's a horizontal asymptote at negative 1. So and we're crossing at 8, so you have to do a plus 9.
Okay. Good thing you're here. How would that one?
All right, so that would have been...
That's the original.
That's the function that we're seeing.
Yes. So we want to subtract 4 from it.
Right, so that'd be the plus 5.
So then negative 3 to the x plus 5. All right.
Yep. That's two lines intersect at exactly 1 point, forming two acute angles and two obtuse angles. The measure of one of these angles is 9x minus 140 degrees. Which of the following could not be the sum of the measures of the two angles? Okay. So what are you thinking on this one?
I don't know. What? Okay. We know that's one of them. The measure of one of the angles is this.
Okay. So then what would the other expression be?
That minus 180 minus all of that.
Yep. So 180 minus a negative 140, so that would be adding a 140. So that'd be 20 and 12, so 220. No, not 220.
320.
320.
And if they intersect, they're all going to have to be the same, like their vertical angles. So that's going to have to be 9x
Yep.
minus 140, and this one will have to be the 320 minus 9x.
Okay.
And then it wants which of the following could not be the sum of the measures of any two of the angles. So, okay, we could have,
So if you add these together, that would be the vertical angles together. It's going to be,
right.
It's really just double that. So it's 18x minus 240. So that would be one possible.
I think you meant 280.
Oh, 280. Yep, 280. So that would be the sum of those. And then what would the sum of these be?
180.
So you would
So make a
have,
straight line.
that would be 180. And then what would the sum of the other ones be? So that would be 320 and 320. So that would be 640. And
minus
then
18x.
minus 18x. Okay.
For
So
answer choices, we've got negative 18x plus 280, which is just the negative of that. So can't be that one. Negative 18x, right? Plus 640. Is that what we have? That's the opposite of what we have. And then 18x minus 280. Uh-oh. So then I messed up somewhere.
now I was going to say it's which one can't be the sum. So 180 is a possible sum. So it's not that
Right.
one. And then 18x minus 280
was.
is a possible sum. And then the
Yes.
640, that's so it's the first one. The first one can't be a sum.
Ta-da.
You can tell it's the end of our workday. All right, the given equation, 2x plus 9y equals 7, is one equation in a system of two linear equations. If the system of equations has at least one solution, which of the following equations could be the other equation for the system? Ooh, okay. So what I would do is I would probably isolate one of the variables in the given equation and then plug them into 1 and 2 and see if they can make an identity.
Okay.
That's probably what I would do.
So let's see, which do you want to solve for?
I would say let's solve for, so 13.5, that's the same, well, double 13 is 26. So would that be like 27 halves? Is 13.5?
Probably.
Okay, 27 halves. Well, that's the same thing as multiplying this one by 3 and then dividing by 2, right? So if you take this equation, so multiply everything by 3 and then divide by 2.
So multiply everything by 3. And then divide by 2. Which is one of them. So
Okay,
definitely one.
Yeah, that overlaps with number 1. There's an infinite number of solutions there. So, because it's the same one, right?
So then it can't be 1 because we want exactly one solution.
It says has at least one solution. So 1 or more.
The
So
given equation is one equation. If the system has
so
okay. So
1 is definitely a possibility. So then now that we have that, actually you could just take these. You just, since 1 is identical to this one, you could
this
then
one's going to intersect at one time.
add them together. So that's going to be 21 right? And that would be 6. That would cross at one place. So would it be both of them? 1 and 2? All right. Looks like that's going to be answer choice C.
C. 1 and 2.
You know, I love how we didn't do exactly what I said I was going to do.
It's okay.
Oh, fractions. The first thing I see is this fraction.
Yeah.
Fractions are our friends, remember?
That's what I say.
A right rectangular prism has a base area of 24t square centimeters. That's a nice rectangular prism.
Yeah, let's put that right angle in. And the base is down. I always say the base is down here.
Yep, that's what I always say.
So it's what? 24T?
24t.
24T.
Okay. The length of the base of the rectangular prism is 8/3 centimeters, and the height is 15.
Okay.
Okay. Which expression represents the surface area in square centimeters of the right rectangular prism?
So my first thought is take that 24 and divide it by 8/3 to get this side.
Okay, yeah.
So 24, it's really 3/8, 3, so 9.
Okay.
T, because that doesn't have a T.
Oh, yeah, yeah. Mm-hmm.
Okay, and now the surface area, go to that. Is there a surface area formula? I know it's given on the
No, I
outside.
know what it is, though.
Oh, okay. I was going to say there's
just
two
find it.
bases.
You just find the area of all the sides and so there's 3 separate sides and you double
Right.
all those sides.
Right, so there's 2 of them that are the base. Which
Well, you already
is-
know the bottom one. The bottom one's
24.
24t, and there's 2 of those. That's the top and the bottom.
Right, 24T. And
Yep.
then there's 2 that are
That's
15
90
by
and
9.
45, so 135t times 2. Yep.
And then there's 2
And then
that are
there's
8/3
8/3.
by 9.
Wait, no, we did the 8/3 and 9t.
Oh, yeah.
8/3
8/3 and 15.
and 15, yep. So 15 divided by
540.
3 is 5, 5 times 8 is 40, yep. Okay. So
So then we get, what is that? 48T plus, what's 135?
200
times
plus
2.
70.
270? And 2 times 40 is 80.
Yep. It's got to be A.
The only one that has
No,
48.
it's 48.
48T plus 3.
Wait a minute. Something's not right. Interesting.
Yeah, that's not an answer choice. Back to the drawing board.
Yep.
So we know that's 24, and that's 24. So we know for sure there's 48T.
Right.
And then we've got this one here that is going to be an 8/3 by 15.
Right. And that's 40, and you double it, so it's 80.
So that's 5 and then 40. So yep, double it and you get 80.
Yep. Okay.
And then the last one is the 9 by 15.
Right.
15 and 9. 135. Which is what we have, but I didn't double that.
So 270. T. 270T.
Ha ha ha! That's where we went wrong. 48 and 270.
318.
Yeah, that would be 11. Yeah, 318.
I was relying on the answer choice.
So 318 plus 80.
Okay, so it's answer choice B.
Okay, and that's, I just didn't carry over my T.
Yep.
So we were right. All right, last one.
All right.
For a particular car, the linear function f gives the predicted power in brake horsepower for engine speeds between, you might have to take lead on this one.
Oh.
Between 1,000 revolutions per minute and 6,000 revolutions per minute, according to this function.
Looks like your domain, 1,000 to 6,000.
The car's predicted power is 433 bhp at an engine speed of 3,331.
Actually, I think that's your range.
RPM. And 600 with a speed of, okay, the equation f of x.
Okay, yeah, so that's the range, 1,000 to 6,000. That's the range. Because it says your function f gives the predicted power. So it outputs RPMs. And it's between 1,000 and 6,000.
The equation where x is the engine speed and RPM, a is a constant. What is the value of a? We just got to pick one of those points then, right? So this one?
Yes.
So there was two points to pick from, I believe, right?
And what is this line at 433? Okay, I was just trying to think of like point slope form. Because your point would be a comma 433.
Right, so that would be your x?
Yes.
Or that's going to be your...
And that's your y. This is your x. Yep, you plug in 433.
The predicted power, though.
Yep, so 433 minus a times the 1/7 is equal to... No. 433 is here. So this is the x. Oh, okay, so I'm dumb. This BHP is... So the units are different. So yeah, this was your domain.
Mm-hmm.
Yep, okay. So that's your x. So it'd be 3331 minus a times the 1/7. Yep. Yep. Has to equal the... Huh.
Okay.
Well, I mean, a would have to be 3,331.
Right, well, that's why I was wondering when you said, hey, the 1/7 x minus a plus 433, this is the y value.
Mm-hmm.
This would be the x.
Oh, yeah.
So if this is our point, then a is going to have to be...
I gotcha. Yeah.
Yeah.
It's been a long work day. So I don't know how we were on time.
About an hour. But give or take,
But we were rambling a little bit.
Yeah.
All right.
All right, we'll do the calculator active portion in the next video.
Right. Hopefully you were able to learn some things or at least get some laughs out of this or some quality entertainment here.
Exactly.
Until next time.
See ya.